Okay, hope everybody is enjoying their spring break so far and is ready to get started on the new material that we are going to start covering today. This is the first of a series of lessons where I basically do what I would normally be doing in class with the lecture and review, and then working you through a few problems before you do some practice on your own. Before we get to ionic bonding, let's talk a little bit about why they will bond. Let's start with magnesium first of all. Magnesium, as you look at it, you already know it has 12 protons because of the atomic number, and it also has 12 electrons. Because this is a normal atom, the protons and the electrons are going to match each other. And then when I figure out the number of neutrons, I'm going to take the atomic mass minus the atomic number and give me 12 neutrons there. Now that I know that I have 12 electrons, I need to map them out in a Bohr diagram. Now the first ring, the first orbital, it only holds 2 because it's the small ring closest to the nucleus. So I'm going to go ahead and put my 2 electrons there. But I need 12, so I'm going to go up to my next ring. Now this next ring will hold 8 total. So I'm going to go ahead and 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 2 tells me I have 10, but I need 12. So I'm going to have to go up to a third ring. Now this third ring in the Bohr diagram, it'll hold 8, but it only needs 2 to get to 12. Now out of these 12 electrons, 2 of them are what we call valence electrons. These are the electrons on the outside, and these are the ones that are actually going to be involved in doing the bonding. And that's why they're so important. And if you look at the top of the periodic table I gave you with your packet, you'll see at the top of magnesium's column, I wrote 2Ve to let you know everything in that row has 2 valence electrons, and everything will end up giving a +2 charge. That's because of the octet rule. Atoms tend to gain, lose, or share electrons so that the valence electrons have a filled outer shell. To give away 2 than it is to go and find 6. Metals will always give away their valence electrons because it's much easier for them to give them away than it is for them to try to find them. So let's take a look at this worksheet right here. Now, when you look up at the top, we got sodium and chlorine. Sodium has 1 valence electron. When you look at sodium on your periodic table and you go up to the top, you see it has 1 valence electron. So when you draw the Lewis dot structure, you put the 1 dot. Now let's find chlorine. When you go find chlorine on the periodic table and go up to the top, it says it has 7 valence electrons. So you've got 1 out of 8, and you've got 7 out of 8. It's much easier to go and give away 1 than it is to find 7. Whereas with chlorine, it's already at 7. It's much easier for it to give away 1 than it is to find or give away. It's much easier for it to find 1 than give away 7. So sodium's wanting to give away an electron, and chlorine wants to take an electron. So when that electron gets moved over, the sodium ends up being a positive charge and the chlorine ends up being a negative charge. Everybody's happy. Now, let's start down here at number 1, K. K, potassium, has one valence electron, so I'm going to put one dot. Fluorine, when you look it on the periodic table and you go up to the top, it has 7. So I'm going to put my F with 1, 2, 3, 4, 5, 6, 7. Now, potassium has 1 out of 8. Fluorine has 7 out of 8. It's going to be much easier to give away that 1 than it is going to be to find 7. So potassium is going to say, hey, come and take that electron. And fluorine's going to be much more happier finding 1 than it is giving away 7. So it's going to be, sure, I'll take that electron. So you're going to end up with K having a +1 charge because it gave away 1 electron. And fluorine is going to have a -1 charge. And there we go. That's how it works. Now, if I give away an electron and somebody takes an electron, there's nobody's making anything with that. So they're going to cancel each other out. So the positive one and the negative one cancel each other out. So we don't have to do anything. So the final formula is going to be KF. So let's take a look at magnesium. We just did magnesium. And with magnesium, we have 2 valence electrons. So I'm going to put my 2 dots there on my Lewis dot structure. And then iodine has 1, 2, 3, 4, 5, 6, 7 valence electrons. Now, magnesium wants to get rid of its electron. So it's going to give this electron over to iodine. But iodine already has 7 out of the 8, and it won't take 2 electrons. But magnesium isn't going to be happy with giving away just 1. So it's got to give that electron to somebody else. But this iodine won't take it, but a different iodine will. So one of these electrons comes to this iodine, and the other magnesium electron comes to this iodine. So let's take a look at that. So we've got magnesium, we got 1 magnesium, and we've got 2 iodines. So M1I2. Now, let's take a look at beryllium. Beryllium is Be, so I'm going to write my symbol. And then if I look at the top of the Be, it has 2 valence electrons. So I'm going to put 2 dots there. Now, S for sulfur. It has 6 valence electrons. 2, 3, 4, 5, 6. Beryllium wants to lose 2. Sulfur wants to take 2. So these electrons are going to zoom over here. Beryllium is going to give up his electrons and be happy. Sulfur is going to take 2 electrons and be happy. So beryllium is going to have a +2 charge. Sulfur is going to have a -2 charge. +2 and a -2, those cancel each other out, right? So they're canceling each other out. So we're going to end up with a formula of BES. Now, let's take a look at number 4 here. We got Na, sodium. So I'm going to write my symbol there. And sodium has 1 valence electrons. Now, oxygen has 1, 2, 3, 4, 5, 6. Now, sodium has 1 out of 8, which means it's going to give away its electron rather than try to find 7. Now, oxygen has 6 out of 8, which means it needs 2 electrons to be happy. But sodium's not going to give it 2. It's only going to give it 1. But oxygen's going to get another electron, not from this sodium, but from a different sodium. So you have 1 oxygen and 2 NAs. And that is the basis of what happens with ionic bonding. Now, there's a couple more on this paper. Try those out. Now, flip the paper over to the back, and you see some of the formula, basically like what we've done. Let's take a look at lithium. Lithium has 3 protons. If it has 3 protons, it has 3 electrons. Now, take a look at lithium on your periodic table. You go up to the top, and it has 1 valence electron. So, the symbol is Li, and it has a Lewis dot structure of Li with a single dot. Now, if you've got 1 out of 8, it's much easier to give away 1 than it is to find 7. So you're going to lose 1 electron. And if you lose 1 electron, you're going to have a positive 1 charge. Let's take a look at chlorine. Chlorine has 17 protons, 17 electrons. And out of those 17 electrons, there are 7 valence electrons. So for our Lewis dot structure, we're going to put our Cl, and we're going to put 1, 2, 3, 4, 5, 6, 7. Now, if we've got 7 out of 8, it's much easier to find 1 than it is 7. So I'm going to gain 1 electron. Now, if I gain an electron, I'm going from 17 to 18 electrons, which means I'm going to have a charge of -1. And there we go. Now, when you look down here at the bottom part of this paper, right here, this is where we're going to start doing some of the true bonding stuff. So let's start with this, sodium and chlorine. Sodium is Na, and go find on your periodic table up at the top and look at the charge. Now, sodium is always going to have a +1 charge. Chlorine is Cl, and it is going to always have a -1 charge. Now, you can do the way we were doing it with drawing the dots and moving it around, which is great to show you what's going on, but it's not a realistic way to do it. So today we're going to show you crossing over, which is what you do when you're actually doing it on a test. Now, a +1 and a -1, those cancel each other out. So in that case, when they cancel each other out, a +1 and a -1, a +2 and a -2, a +3 and a -3. When they cancel each other out, you don't do any crossing over, you just put them together. So it's NaCl, and that is the formula for sodium and chlorine when they come together. There's no numbers, it's just smashing it together. Now, let's take a look at aluminum and fluorine. Now, aluminum is Al, and when you look at the top of that row, it's a +3 charge. Fluorine is F with a -1. Now, +3 and a -1 don't cancel each other out. If I give you $1 and you give me 4 quarters back, nobody made any money. That's basically what comes down to when it's canceling out. But a +3 and a -1 don't cancel each other out. So you have to cross over, which means I'm going to take the 3 and I'm going to put it here, and I'm going to take the 1 and I'm going to put it here. And I ignore the charges. So the 3 moves, but not the positive part. So I'm going to put my Al, then the 1's going to move over, then I'm going to put my F, and then I'm going to move my 3 over. So my formula is Al with a subscript of 1, F with a subscript of 3. Now, when you're doing this, you need to do a couple things. Number 1, you need to make sure that these subscripts are down, and because if you write Al1F3, I'm going to mark it wrong. You need to make sure you're doing it with a subscript, not a normal size script. Don't move the positive and negative over. Also, when you're doing this extra step right here, this work, you have to write it down. If I see your paper and the only thing you have is AL1F3, I'm going to mark it wrong and not give you credit for it. You have to show the work. You have not been doing this long enough to be able to do this in your head. Now, once you've been doing it for a while, if you want to be able to do it without writing it down and jump straight to the answer, that's fine. But right now, in this class, you have to show this work in order to get credit, period. Let's take a look at magnesium. Magnesium is Mg, and it has a +2 charge. So I'm going to go ahead and write that magnesium +2 charge. Fluorine is F with a -1. Now, +2 and a -1, they don't cancel each other out. So I'm going to take my 2 and put it here, my 1 and put it here, and my formula is going to be MgF2. Now, if I want to put my 1 there, that's fine. Doesn't change the answer. It's an invisible understood 1. And that is your answer. Remember, make sure to check capitalization. Make sure that the numbers are the right place. And you show your work. Let's take a look at aluminum and sulfur. Aluminum, Al, with a +3. Sulfur is S with a -2. +3 and a -2 don't cancel each other out. So I'm going to take my 3 and put it here, and my 2 and put it here. And I'm going to end up with Al2S3. That's my answer. That's my work. Got to show it.